Guys, welcome back my YouTube channel. I'm Ketek. Now we start our remaining lecture, the explanation model. The most accurate description of the diode operation in the forward region is provided by exponential model. Unfortunately, however, its several non-linear nature makes this model the most difficult to use. To illustrate, let's analyze the circuit in figure 4.10 using the exponential diode model. Assuming that VDD is greater than 0.5 V, so the diode current will be much larger than the IS, and we can repeat the diode IV characteristic by exponential relationship in ID is equal to IS EVD over VT. The other equation governs circuit operation is obtained by writing a Kirchhoff loop equation resulting in IT VDD minus VD over R. Assuming that the diode parameter Is is known, equation 4.6 and 4.7 are two equations in the two unknowns quantities ID and VD. Two alternative ways for obtaining the solution we are graphically analysis and iterative analysis. Figure 4.10, a simple circuit used to illustrate the analysis of circuit in which the diode is forward conducting. 4. Graphically analysis using the explanation model. Graphically analysis is performed by plotting the relationship of equation 4.6 and 4.7 on the IV plane. The solution can be obtained as coordinates of the point of intersection of the two graphs. A sketch of the graphical constructions is shown in figure 4.11. The curve represents the exponential diode equation 4.6 and straight line represent equation 4.7. Such a straight line is known as load line, a name that will become more meaningful in later chapters. The load line intersect the diode curve at point Q, which represents the operating point of each of the circuit. Its coordinates give the rules of ID and VD. Graphically analyze aids in the visualization of circuit operations. However, the effort involved in performing such an analysis, particularly for complex circuit, is too great to be justified in practice. Graphically analysis of circuit in figure 4.10 using the exponential diode model. This is exponential diode model. Alternative analysis using the exponential model. Equation 4.6 and 4.7 can be solved using a simple iterative procedure as illustrated in the following example. Example 4.10, illustrate an analysis using exponential model. And solution is also given. The need for rapid analysis. The iterative analysis procedure utilized in the example above is simple and yields a accurate result after 2 or 3 iterations. Nevertheless, there are situations in which the effort and time required are still greater than can be justified. Specifically, if one is doing pencil and paper design of relatively complex circuit, rapid circuit analysis is necessary. Through quick analysis, designer is able to evaluate various possibilities before deciding on a suitable circuit design. To speed up the analysis process, one must be content with less precise results. This, however, is seldom a problem because the more accurate analysis can be postponed until a final or almost final design is obtained. Accurate analysis of the almost final design can be performed with the aid of computer circuit analysis programs such as SPICE as Appendix B and the disk. The result of such an analysis can then be used to further refine or fine tune the design. To speed up the analysis process, we must find a simpler model for the diode forward characteristics. Now we close our lecture in this topic, and remaining lecture will discuss in next video. Don't forget to subscribe my YouTube channel MK Tech.